If you ask the mainstream research community, they don't want to prolong life, they want to prolong health. But the assumption is that the total life will remain fixed. But that's just an assumption. And so if you were to say improve healthy aging, there's no guarantee that you wouldn't start to live longer and you would have the same decline, only you've postponed it now by a decade or so.
Alter, was geht? Der Podcast, in dem dich Elmar Stracke durch die Geschichte und Gegenwart des Alters führt und dich mit Anekdoten und Fun Facts ausstattet, damit du bei der nächsten Party ganz sicher nicht alt aussiehst.
Hello and welcome to Alter, was geht? Perhaps many of you are familiar with this podcast, but some of you might be new to the game, partly as this is the very first episode in English. So what is Alter, was geht? To begin with, it's a pun, a play at words, meaning both what's up, man, and what's up, old age in German. But then it's also a podcast that you're currently listening to on questions of age and aging, sociology, history, biology, philosophy, and all the other dimensions through which we can have a look at one thing that we all have in common. We grow older every single day. So far, I've had the pleasure in this podcast to have guests from science, civil society, politics, from journalism, that covered a wide variety of topics. Generational relations, loneliness, future of pension scheme, aging in antiquity or in other countries such as Korea, Russia, Japan. All the different ways of aging in the animal kingdom. If you feel intrigued and interested, please feel free to tune in the older episodes. However, be aware that they are all in German. Unlike this one. The reason why this episode is in English is quite easy to explain. It's the first time that there's a guest that doesn't speak German, but he speaks, fortunately, English. And it's definitely worth making this change for this episode because what he says is important to everyone. Because everyone will inevitably die. And our guest is the ideal person to explain why. And that is not, because he has personally experienced dying himself, fortunately, but because of his research. I am very happy to welcome as a guest Venki Ramakrishnan, an Indian-British-American structural biologist who in 2009 was awarded the Nobel Prize in Chemistry, together with the US-American molecular biologist Thomas A. Stites and the Israeli structural biologist Ada Yonath. I had the pleasure to talk to him because he came to Germany to present his latest book. And in that book, he combines all he knows about chemistry and biology, as well as all the people he has met in these fields to explore exactly this question. Why do we die? And there's a lot of interesting aspects to it. Is there maximum length of life? Can we make aging slower? Can we freeze our bodies? How should we deal with death in society? All of this will be part of this episode. And the episodes of Alter, was geht are always structured this way. There are 3 parts. Let's say 2 content parts. And in the middle, there's a fun fact part, an interesting anecdote or figure. And that one, Venki Ramakrishnan has also brought to us. And essentially, you will learn that you shouldn't eat your relatives' brains, at least not raw. Enjoy the episode. Mr. Ramakrishnan, I'm very happy to be here with you. Thank you very much for coming and joining Alter, was geht. Your latest book has the title Why We Die. But then when you read it, you might also think the name would be Why We Age. How come you've picked this one and not the other title?
Because I think of death as aging is a much harder process. It's a continuous process, and it's not a fixed endpoint. And whereas death is the endpoint, and so I think people want to know. People are interested in that endpoint. And so that's really why I think the title is a bit more punchy if you say why we die.
And while we are aging, what have you learned? So maybe in a nutshell, why do we age and why do we die?
I think you can think of aging as a accumulation of changes and defects, damage and changes. Now, not all the changes are technically what you would call damage, but they all have the result of making things not optimum in terms of their function. And that's the whole process of aging. And when it accumulates to the point where you have a system failure of some critical system, like the heart or the brain, then the organism is unable to exist as a coherent unit. So it doesn't mean, so there's a curious thing about it, that when we're alive, millions of our cells are dying all the time. And we don't even notice it. And in fact, some of them, many of them have to die in order to have normal function of the body. But in contrast, when we die, most of our cells at the point of death, most of our cells are still alive. So what does it mean, when you say you die? Because you can donate your organs to somebody and they will continue to work in the new body, right? It means that you can't function as a whole individual.
Once I read about a comparison to a car, something like you can change every part of a car, but at a certain point, it's just over. So you can't use another spare part. The car is just broken. Would you say that's a useful analogy?
I think the car is a somewhat simplistic analogy because a car is made of very defined parts. You can buy parts which are brand new. You can in fact reconstruct a car from a completely new chassis. I did that once with my bicycle. Only the frame is the same, but it has new wheels and new gears, and everything's different about it. And even the frame has been repainted. So it's not the same. I think with a body is much more complex and networked, all the parts of the body. And there's also communication at many different levels, from the molecular level to the ensemble of molecules to the cell, and then the tissues that make up the cell and the organism. And these different levels all talk to each other. So they don't exist in isolation. And so I think it's more complex than an analogy like a car.
I really like the analogy that you're making in your book with the city, saying that the human body is a bit like a city, in particular also with the point of view of existential philosophy. So no one can imagine dying, but also, so it's always the others who are dying, but we can't imagine either that we live in the city that won't exist anymore, or that will be deserted one day.
I actually make an analogy even to a simple life form like a cell. So a cell has a membrane which allows import and export. So you can think of it as a border control. It has a nucleus, which is like a command center, where your genome is. It has trafficking, which takes, so this is like transit systems, which can take molecules or organelles from one part of the cell to a really distant part of the cell. So there are lots of analogies, equivalences between this, and it has a waste disposal system. It has an energy production system, which would be like our power plants. So there are lots of analogies that you can make between a city and a cell. And of course, all life form is a collection of cells. Now, the interesting thing is that you're right. There are cities that don't exist anymore that were thriving. And I give the example of Hampi, which is a historic city in South India, which at one time was one of the largest cities in the world and was a big center for trade and a cultural center. And now it's a collection of ruins visited by tourists. So I do think that analogy is true.
So I think the analogy is very useful to understand cells, organisms, etc. Is there anything the other way around, that our design of cities that we could learn from the organism for our cities?
Well, one thing is cities should be easily renewable. So when you have decay, they should, you should be able to get rid of old parts that you don't need and be able to restore constantly. So a city has to be constantly renewing itself to be vibrant and alive. A city needs good governance. So the importance of government and participation, that's also very important. And, a cell is a democratic government. DNA is not like a sort of dictator that dictates what happens. It's a constantly gets input from the environment about what genes to turn on and off. So it's not like a master in a dictatorial sense. So you can think of it as a highly responsive democratic government.
So we're all aging every day, but what I think is very interesting, and we take it for granted, and then it's not at the same time, is no matter what age we have, when we reproduce, our children are all newborn. They all start at zero, so to say. What does that mean? Doesn't that mean that we somehow carry eternal youth within our bodies?
Yeah, it is a slight paradox that our bodies decay and die, but something in us has existed for a very long time. For example, the cell that gave birth to us came from cells in our parents, which came from cells from their parents, all the way back to go a few billion years to the start of life. So all life really may have come from a what's called the last universal common ancestor. And so there is this continuity to life, even though individual bodies decay and die. And you're right, when our children are born, they're born at age 0. It's almost as if the aging clock has been reset. But that's due to a complicated set of conditions. So the first is that the germline from which the fertilized egg is made, so the egg and the sperm which unite, those germline cells are less susceptible to DNA damage and other kinds of damage. So they're better protected. But that's not enough, because they do get damaged only at a smaller rate. But then they're also highly selected. So, for example, a female, a human female is born with over 1 million precursors of eggs. But if you look at the number of menstrual cycles a woman has over her lifetime, it's only a few hundred, okay? And so then you have to ask, what happened to these million? Well, the thing is that for each egg that is actually makes it to ovulation, there's a lot of selection. There's a lot of other eggs which don't make the cut because they're defective. They're tested and found defective in some way. And this happens increasingly with the age of a woman. And that's why later in life, it's also harder for a woman to conceive. Now, the other thing is that even after the fertilized egg starts developing, many of those developing embryos don't make it because they're defective and they're spontaneously rejected. And even the embryo that have survived, within the embryo, defective cells are eliminated. So there's a great deal of selection, brutal selection and better protection, and a large amount of starting material that goes into making sure that what the child is born, healthy and age 0. And as you know, the system's not perfect. Many children, unfortunately, are born with problems.
Leonard Hayflick, very prominent biologist with groundbreaking research, I think, who just passed away. He once said in an interview with The Lancet that, I quote, "The invention of ways to increase human longevity is the world's second oldest profession, or maybe even the first." And what I think is interesting, so I think about the, conventionally speaking, very first profession, not much has changed within the decades and centuries of humankind. But about the second oldest profession, so increasing longevity, I have the feeling we're on a good way. There are things happening, or there have been things happening over the past, in particular, 150 years. Will there ever be a limit? Will there ever be a point where we say, well, I mean, that's it. Longevity has reached its ceiling?
Well, some scientists would argue we're already reaching that ceiling. For example, J. Olshansky, who I've also mentioned in the book, recently came out with a paper, I think just this month, which points out that the gain in life expectancy has diminished and is plateauing off. And the idea is that we are not all going to suddenly start living to be 100 because of advances in medicine. So our natural lifespan may be reaching its limit. But even Olshansky would point out that if you can attack the causes of aging itself, not just eliminate this or that disease, but if you can actually slow down or possibly even reverse the processes of aging itself, then you might be able to extend lifespan. But that's a much harder problem. And I agree with Olshansky that it is not going to happen very soon. It will take time. But there are others, of course, who are much more optimistic. You may have heard of his famous bet with Stephen Ostad. They made a bet that the person to live to be 150 has already been born. Olshansky has bet against it. I would probably support Olshansky. But Stephen Ostad's feeling is there are so many things that are being tried and are coming out and there's also so much money going into research that eventually there'll be breakthroughs. So I think that's where the disagreement is.
Fun fact.
Mr. Ramakrishnan, in each episode of Alter was geht, the guest brings a fun fact, an anecdote, an interesting figure that one can easily remember. Do you have that something in this area, something that people can remember?
Well, I can give you a couple of examples from the book. So one of them is by this guy who was Carlton Gajdusek went to explore this tribe in Papua New Guinea and showed that they were transmitting Kuru disease because they were eating the brains and other parts of their ancestors as part of a memorial service. They wanted to somehow capture the spirit of their ancestors. This was part of their ritual. And this turned out to be a proteinaceous disease. So you had a misfolded form of protein that then, triggered other proteins of its kind to also misfold and form maybe aggregates. And then fast forward many years, and we find that this is maybe the sort of thing that is happening in dementia, which is one of the big problems as we age, and one of the more, I think, problems that is most difficult to solve because it involves the brain, and it's also very complicated, both as a phenomenon and to think of therapy. So that's one interesting example. Another is the discovery of the TOR pathway, which is a major pathway that is affected by restricting calories, and it's involved in aging as well. And the discovery was very curious. It started off by people exploring Easter Island, which was called Rapa Nui by the inhabitants, and looking for soil bacteria that produced antimicrobial compounds. And from that came out rapamycin. And rapamycin then was shown to be the inhibitor of this completely unknown pathway. So it went from Canada via Easter Island, and there was an Indian Canadian scientist who took it with him to the US and developed it. And then the story then started a new chapter in Basel in Switzerland when two Americans and an Indian collaborated to discover this pathway. And one interesting thing about it is these people were not looking to study aging. They were just following their curiosity about something or the other, and it later on turned out to have a connection with aging. And that's often how science works.
We've already established that it won't be terribly easy or probable that we will reach eternal life anytime soon. However, there are certain people who claim that this is going to happen via transhumanism or via cryotech, so freezing the dead body so you can wake them up and then they will resurrect from the death happily one day. How likely is that?
I think it's extremely unlikely. And let's take the cryo thing first. We know how to freeze very, very small biological samples. We can freeze cells, we can freeze eggs, we can freeze even embryos or larvae of worms or flies. So there are many specimens that we can freeze in order to be able to use them later. And people do this routinely in biology. But as you get to bigger animals, it gets progressively harder because what you have to do is preserve all of the cells intact. That is extremely hard because water, as you know, expands when you freeze. And people have not even frozen a small animal like a mouse and revived it. So the idea that suddenly they're going to freeze, they know how to freeze humans and revive them is crazy. The other is that, remember, the way they're doing it is the person dies and they're filling the person with some fluid, like an embalming fluid, it's a kind of antifreeze to prevent this ice formation. And then they're freezing it. Nobody has any idea. And by the time that happens, the person's neurons have all gone through all sorts of damage and so on. And even if the connection between the neurons is preserved, which they have done, by the way, for a mouse, they've killed the mouse in the process, and you don't know the state of each neuron. So this is purely in the realm of science fiction. And the idea that you can take your brain dump and, dump it onto a computer is even more science fiction. And I'll give you a simple paradox with it. Supposing it was possible that you could dump your brain into a computer, well, then you could make a copy of that computer. So which one would be the real you? You see the problem? There's a real paradox there. You'd have two people fighting to say, "Oh, I'm the real Venki." I mean, it's complete nonsense. So I just don't see either of these as realistic.
Yes, I think you're very right about the implications we have for the legal system, for philosophy, etc., in terms of identity, for instance. One maybe last thing that I wanted to know is, what do you think we can expect? So modernity is bad at dealing with losses, so we don't want to see death. I don't know about the US and the UK, but in Germany, for instance, if I compare to my childhood, we used to have funeral cars, so hearses. They have entirely disappeared from public life. It's just transporter vans with a little bit different branding nowadays. So another sign of how death has disappeared from society. I don't know if that's a good thing or bad, but
I think it's very bad. It means, people are disconnected with the idea that there's a cycle of birth and life and death, and then new generations are born. And in that sense, I think older cultures which were closer to death, and people also now die separately. They die in hospitals or in care homes. They don't as frequently die at home in a normal setting. And I think that isolation is not really a good thing. I personally don't like it. The problem is none of us wants to die. We have all evolved to want to live, because otherwise we wouldn't have succeeded in the evolutionary sweepstakes. If we hadn't desperately wanted to stay alive whenever we could. And so I think that fear and that desire to live, the fear of death and the desire to live, is driving some of this.
And do you think there will be more progress in terms of compressing mobility so that we can prolong our healthy lifespan?
That's the goal of the mainstream aging research community. If you ask the mainstream research community, they don't want to prolong life, they want to prolong health. But the assumption is that the total life will remain fixed. But that's just an assumption. And so if you were to say improve healthy aging, there's no guarantee that you wouldn't start to live longer and you would have the same decline, only you've postponed it now by a decade or so.
Bookstores are full of advices on how to age happily, safely, slower, whatever. What advice would you give to people who, besides, obviously, and that would be my advice, reading your book first, so you have a solid ground?
Well, I would say to eat moderately and to exercise regularly and to sleep adequately. And all of those affect many of the pathways that we now know are involved in aging.
Would you say these factors or these pathways are very compatible with the life of a researcher?
They can be, yes. I think many researchers do exercise, and I don't know about the sleep part, but they certainly exercise and often will eat well and so on.
Mr. Ramakrishnan, I've been given many inspirations and insights from this interview, so thank you very much for that. However, I don't want you to leave empty-handed either. Therefore, as all of the guests of this podcast, I'm happy to give to you the Alter, was geht mug that can always remind you that there's only a thin line between how are you and how will you age happily and safely. Thank you so much. It was a great pleasure, and good luck with the book. A strong recommendation to everyone listening to read it, to buy it. It's very worthwhile. And thank you very much for the interview. This was Alter, was geht with the Nobel Prize laureate Venki Ramakrishnan on his latest book, Why Do We Die? I hope you enjoyed the episode and you have learned a lot on our prospects on slowing down death, what we can hope for, what we should maybe not hope for, and why death should be more present, at least in Western societies, than it is now. I mean, that's at least what I think, and also what Venki thinks. But what is your opinion? Is the way we deal with death now and how we strive to live forever good or bad? Let others know in the comments of Spotify, Instagram, LinkedIn, and wherever you follow this podcast. And most importantly, please don't die, even if you know why now. Partly because as long as you are alive, you are still able to tell others about this podcast, leave a review or a few stars. That would be my pleasure and perhaps the pleasure of others as well. Special thanks for this episode to Daniel Cordes for his great technical support, to Klett Cotta Publishing House, who made this episode possible, and obviously to Venki Ramakrishnan. May we all live long, happily, healthily, but perhaps not forever. And may we hear each other again in the next episode of Alter, was geht?
Das war Alter, was geht mit Elmar Stracke. Hoffentlich hören wir uns bald wieder in alter Frische.